Hello everyone, happy to see you here. Welcome back to my channel Higher Mathematics. Today we have a very interesting and tricky question. A to the power 4 equal to a minus 1 to the power 4. We need to solve this question for a, so if you have your answer, your solution, you can write it in the comments below and then we will check our answers. Okay, so first of all, I'm going to start with one really interesting moment because a lot of students might be thinking that we can cancel this force power. Okay, we can cancel it from here, and as a result, what we can have like a equal to a minus 1. A lot of students might be thinking that this is a correct way. We can do it, okay? We cancel it, but as a result from here, we have, if we subtract a from both sides, we have 0 equal to minus 1. And then a lot of students might be thinking maybe this question has no roots right here because something like that. We have a really weird expression, 0 equal to minus 1. And right now I'm going to show you how we can solve this question correctly and step by step, because this is absolutely wrong approach. Okay, so first of all, instead of this a to the fourth, or let's rewrite this expression on the left side. Let's start with this thing. So a to the power 4 minus a minus 1 to the power 4, a minus 1 to the power 4 equal to 0. So everything we write on the left side. What we're going to do next, instead of this a to the power 4, I want to write a square to the power 2. We can easily do this, okay? And the same thing I want to do with this expression. So a minus 1 to the power, not 4, but let's raise to the power 2, and let's raise once more to the power 2 equal to 0. So I really hope you understand this first step, because there is like really important property. When I have a to the power x raised to the power y, we can write it as a to the power x times y, and that's why I split it like that. Okay, secondly, what we're gonna do right now, let's look at this question like from a different angle, because this is a square. For example, this is our expression 1, this is our x, and this expression a minus 1 to the second power, this is our expression y. So we have, what do we have? We have x square minus y square. So this is our school identity, x square minus y square. So we can write it x plus y, as x plus y times x minus y. And right now, let's apply it right here. We can easily do this difference of two squares, okay? So let's do it right now. The first one we have, let's go with the negative sign or with the positive, doesn't matter. First of all, what do we have? A square minus a minus 1 square, or plus, doesn't matter. Let's go with the negative first. So a minus 1 square, and the second one, a square plus a minus 1 square equal to 0. So right now we have a product equal to 0 when this parenthesis equal to 0, or this one. So everything is great. But before writing two equations, let's simplify this real quick. So first of all, on the left side, what do we have? A square minus, and this is our school formula, a square minus 2a and plus 1. And the second one, a square plus, this is also our formula, a square minus 2a and plus 1 equal to 0. Right now, let's simplify this real quick. Let's open our parentheses, because what do we have? A square minus this one, we need to change all the signs to the opposite one, minus a square plus 2a and minus 1. Right here, we need to get rid, we can easily get rid of this parenthesis. So we have plus a square minus 2a and plus 1 equal to 0. Really great. Right now, what can we simplify? A square and a square, we can easily cancel it. A square plus a square equal to 2a square. Okay, so let's continue. On the left side, we have 2a minus 1, only 2a minus 1. On the right side, we have this one, 2a square minus 2a and plus 1 equal to 0. Okay, really great. So a product equal to 0, as I said before, a product equal to 0 when the first parenthesis is equal to 0, so 2a minus 1 is equal to 0, yeah? Or this one, or this expression equal to 0, so 2a square minus 2a and plus 1 is equal to 0. We can solve this equation instantly. From here we have 2a equal to 1 and a first equal to 1/1/2. Okay, yeah, we have a first equal to 1/2. What can you say about this equation? This is basic quadratic, a classic quadratic equation. Let's solve it with the basic method of coefficients. Of course, this is up to you how you prefer solving this type of question. For me, the great way to solve it, and of course maybe a lot of students watch my videos, so it's really great to solve in a classic way. So a equal to 2, b equal to -2, and c equal to 1. So let's find real quick our discriminant, equal to b squared minus 4ac. I prefer solving this question first of all with discriminant, and then I'm plugging it in all known formula, in all known spots. So b squared, we have -2 square minus 4 times a times 2 and times 1 times c. Okay, as a result, what do we have? -2 square equal to 4 minus 4 times 2 times 1 equal to 8. So we have 4 minus 8 equal to -4. So our discriminant is negative, is less than 0. So it means that in this branch we will have two complex roots. Okay, two complex roots. So let's solve it. In this case, we're gonna have like a second and third. Okay, equal to -b plus minus square root of discriminant and all over to a. So let's plug in each of these elements into this spot. We know everything. So we have -b minus -2 plus minus square root of discriminant square root of -4, and we're gonna divide it by 2 times a times 2. 2 times 2. Okay, equal to, let's simplify this real quick. So -2, we have, as a result, we have plus, so we have 2 plus minus. This square root of -4, we can easily split it. Okay, we can write it as square root of -1 times 4. We can write it like that. Okay, 2 times 2 equal to 4 in our denominator. Right now, there's like really interesting and quick property. We can easily split it like square root of -1 times square root of 4. We can easily split it in terms of square root. So 2 plus minus square root of -1 times square root of 4. We can easily do this, and we divide it by 4. Right now, square root of -1 equal to I. This is our imaginary unit. Square root of 4 equal to 2. Yep, so as a result, we have 2 plus minus 2i, 2 plus minus 2i, and we divide it by 4. Okay, we divided by 4, and right now the final step, we can easily use both variations, because in terms of, or let's write it in a new line, okay, a second and third. This is our first variation, okay, 2 plus minus 2i over 4. This is our first variation. How can we write it? We can also divide it by 2. Each of these coefficients we divide by 2, so as a result we can write it as 1 plus minus I over 2, or the second way, we can split it by real part and imaginary part, so 1/2 plus minus I over 2. This is up to you. What do you think about it? We have two variations, the first one and the second one, but I prefer this one with the positive sign and with the negative sign. So our a second equal to 1 plus I over 2. This is our second root, our complex root, and we have a third equal to 1 minus I over 2. Yeah, we have right here our third root. So we have three roots. We solved this question absolutely correctly. Right now, let's check real quick our a first. In terms of our question, let's check it, and in that I'm going to give you a few really important thoughts about this question. So in the beginning, what we had, a to the fourth equal to a minus 1 to the power 4. Let's check real quick our a equal to 1/2. So we have 1/2 to the power 4 equal to 1/2 minus 1 to the power 4. And I don't want to simplify that, because exactly at this place you can easily see that everything is great, because 1/2 to the power 4, let's leave it like that. On the right side, 1/2 minus 1, we have minus 1/2, yeah, minus 1/2, but we have an even power, so it doesn't matter, minus, plus, 1/2, as a result, our final sign will be positive, because we have an even power. So our root is great, so this is our real number root, and this root is great for us. A first equal to 1/2. And few thoughts about this question, extremely important thoughts, because in the beginning I wrote one really important thing. So in the beginning, what we had, a to the power 4 equal to a minus 1 to the power 4. And in the beginning, I just said that we can cancel this fourth power. I did it on purpose because I just want you to understand that we can't cancel this fourth power. Of course, we can cancel it, but with one really important moment. A lot of students forget about the thing which is called absolute value. And when you cancel this fourth power, you need to put absolute value brackets right here and absolute value brackets right here. And this is a correct way. Exactly in this case, you can do it. When you can cancel this fourth power, you can easily do it, and as a result, you have absolute value equation with absolute value. And exactly in this case, method of combinations, maybe this positive, positive, negative, negative, positive, or negative and negative. And in this case, exactly in these combinations, you can get a first. You can get a first. And this is extremely important part, because what we had in the beginning we had the thing, we've done it without absolute value brackets, so we just cancel it. We have this expression 0 equal to -1, and this is a wrong way. I just put this sign right here, exclamation mark, yeah? I just put it, and I really want you to understand that if you don't have, for example, enough time on your exam, you don't have enough time to find the complex root, this second part, extremely important part. If you don't have a time, or maybe you don't know how can you find it, so you can easily find real quick a real number root. But don't forget about the absolute value, because without absolute value we have 0 equal to -1. With absolute value we have 4 cases. Of course, this is up to you how you prefer solving this absolute value equation with absolute value brackets. But exactly this case can bring us this root a first equal to 1/2. And why this method is good and why this method is not good? This method is good because when you cancel this fourth power, you can solve this, you can find real quick a first. Exactly, really great. But why this method is not good? Because in this part you can't find complex roots. There is no way you can find in this equation you can find a complex root. So there's like advantages and disadvantages solving this question like that. I recommend you to solve this question with absolute value only if you don't have a time on your exam. You can easily find real quick a first. But if you have a time, this is not the best method. This is like a special case. But the best method is to express this in a different way and to consider it as a difference of squares. You split it and you factor it. The best method is to factor this question. And in this case, you can also find both real number root, and you also have a second branch. And in this branch, you can find a complex root, and you can call it as a full solution to this question, because you start with this canceling fourth part. You show that you can find this real number root with absolute value brackets. You can show it, but then you write that, okay, this is not a full solution, because according to a fundamental theorem of algebra, we have fourth power, this is the highest power, so it means that we have 4 roots in total, so the maximum amount of roots is 4. So basically, one root is not the best way to solve this question. You need to find second and third root, maybe fourth root, so that's why it's also really great that you show this to your teacher. But the correct way to solve this question is to expand it, to factor it, and as a result you have a full solution. Right here, this one, you can call as a full solution a first real number root, and we have right here two complex root. So I really hope you understand my thoughts, because extremely important, this is extremely important. A lot of students do this mistake. A lot of students canceling this fourth part, of course without absolute value, but you need to put it if you want to solve this question. If you want to find this real number root, you need to put this absolute value brackets and then absolutely correct, like a special case. I'm not going to say that this is a solution. This is like a special case to find real number root. And of course you need to expand it, you need to factor it, you need to find the way how can we factor it. And with the factoring is also really interesting and a great method, because with the factoring you can solve this question absolutely correct. Factoring method helps us to find all possible roots, all possible branches, and all possible solutions. So I really hope you understand my thoughts about it. So thank you for your time. Also write your thoughts, write your response in the comments below. Let's discuss a little bit about this question. What do you think a little bit about it? What do you think about this solution? Maybe you have a faster method, your thoughts, your assumptions. It's also really interesting to exchange information because maybe there are a lot of teachers watching my videos, a lot of students, I don't know exactly. There are a lot of people watching my videos, so I really hope you leave your response and you write your solution. Yeah, you write your branch, your way. How can we solve this type of question? So thank you for your time. Take care of yourself and have a great day. See you in the next videos.